the frequencies depending upon the class interval. So you make a table with class intervals and the frequencies. So such a table is called the frequency distribution. So what we do is, whenever you have any raw data, you put that in the table format, and that is nothing but the frequency distribution. There were two types of frequency distribution: inclusive frequency distribution and the exclusive frequency distribution. So this inclusive and exclusive depends upon the upper limit of the class interval. So if upper limit is included, then it is inclusive. If upper limit is not included, then it is exclusive. After that, we saw the class limits, class boundaries, class width, class mark, and what are the open end classes. So in today's lecture, we will go ahead with the cumulative frequency. Cumulative frequency. So in many of the cases, what happens is, like in yesterday's example, we were checking the intelligence for 40 students, and uh, the Aditya said that we see that the number of students who are scoring more than 40 is large, whereas the number of students who are having less than 40 marks is very less. So in this kind of cases, um, what we are actually counting is, we are counting a frequency which is greater than certain number. In some cases, we count the frequency which is less than a certain number. Okay, so what do we mean by cumulative frequency? uh, Cumulative frequency is associated when we need to find the frequency larger than some uh, number, for larger or less than some number. In this kind of cases, cumulative frequency is used. There are two types of cumulative frequency, as you may have heard: less than type cumulative frequency. Less than type, it means that whenever uh, for any of number which is which is included in the class intervals, so I need the frequency, whatever I'm calculating is always less than that number. So I'm going to calculate the frequency for less than some number. In that cases, less than cumulative frequency is used. So the definition is, it is the number of it is the number of observations less than or equal to or equal to the upper limit. Upper limit of the corresponding class. This is the basic definition, which will be better understood how to do this when we go for an example. Say I'll have marks and I have the frequency. So number of students who are having marks in this range, so 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. Frequencies are 5, 12, 15, 4, 4. So the total frequency is 30, 31, 36, 40. Yes. So from this, I have class intervals, I have frequencies, and with that, what we need to do is now we need to find the cumulative frequency less than type, less than type cumulative frequency. Anyone? You just need to read the definition carefully and you will be able to tell me the way by which we can find these frequencies for each class interval.
So the first one would be 5.
Yes,
The second one would be 17.
exactly. Exactly. Thank you, Manas. So what the definition says? A number of observation which is less than or equal to the upper limit. So when we look at the first class interval, upper limit is 10. So all the observations which are below 10. So there are 5. So this will be as it is. Then you look at this, upper limit is 20. So all the observations which are having marks less than or equal to 20, those are going to be plus 5, which is 70. If we go to the next, the third one, 30. So all the observations with less than or equal to 30, so that will be 5 plus 12 plus 15. This is going to be 32. Then all the observation less than 40. So what is 5 plus 12 plus 15, and the last one, this is 4. That will turn out to be 36. And all the observation less than 50. So that is 5 plus 12 plus 15 plus 4 plus 4, that is 40. So this is how you find the less than cumulative frequency. So you can now easily see if I want the number of students who have got less than 10 marks, or number of students who have got less than 30 marks, I can simply look at this interval 20 to 50, upper limit as 30, and I'll go to the cumulative frequency. So 32 students have got marks less than 30. Right? So this is the use of less than cumulative frequency. Then there's another type of cumulative frequency which is called more than type cumulative frequency. It is the number of observations, it is the number of observations more or equal to lower limit of the corresponding class. Lower limit of the corresponding class. Again, I write down the marks 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. And the frequency for the same is 5, 12, 15, 4, 4. So more than type cumulative frequency. Anyone other than Manas?
So 40,
Exactly. The first entry is going to be 40.
then 40 minus 12.
Sure.
So 40 minus 12 will be the second frequency.
Yes. 40 minus 12. Anyone else?
So then 40 minus 12 minus 15, all the frequencies will be subtracted as we go down.
No. Let someone else speak. Is there anyone else who wants to speak?
Sir, wouldn't it be better if we started from the bottom?
I mean, that is the way by which you can write the entries, but we are trying to understand the concept right now. That's why I'm going from the top.
Oh, okay.
Sir, we can just add all the frequencies from that group and the next one. So for suppose 10 to 20, that's 12. So we'll add 12 plus 15 plus 4 plus 4. And for 20
No.
to 30,
So you're telling me to go from the bottom or from the top?
from the top, sir.
Mm.
I-
Whatever
I'm,
I have
I'm
written,
saying,
is it correct? Are you convinced with this, Aditya? Are you convinced
like,
with what is written?
are you talking about the definition?
No, the
Or
table that I have written, first entry, second entry, is it correct, or you feel that it should change?
Excuse me, sir, it's wrong. So 40 minus 5 will come, not 12.
Yes. Okay. Thank you. Now it is correct. So what the definition says is you need the number of observations more than or equal to lower limit of the corresponding class. Now, what is the lower limit for the first class? It is 0. What are the observations which are having greater than 0 marks? That's what I need to see. And all the observations that we have all the observations with more than 0 marks, and that's why this entry is 40. Now, in the second one, what I need to write? The lower limit is 10. So, all the observations who are having more than 10 marks, that is what I need to calculate. So, more than 12 marks, it means all these observations, right? All these are having more than 10 marks, but these 5 have less than 10 marks. So, what I'm going to do, 40 minus 5, which is 35. Then I'll go to the next class, 20. So I need all the observations or all the students who are having more than 20 marks. So what I need to do is 40 minus 5 minus 12. So 35 minus 12, that is going to be 23. Again with more than 30. So that will be 23 minus 15. So that is 8. And the last one is 4. So in less than cumulative frequency, what you do is you go on adding this, and for more than cumulative frequency, you keep subtracting. Okay, that is the idea. Other way around, how can I do is I can go from the lower limit, as Manas said, that this is going to be 4, this will be 4 plus 4, and this will be 4 plus 4 plus 15, then 4 plus 4 plus 15 plus 12, and then 4 plus 4 plus 15 plus 12 plus 5. Both the ways it works, of course, but I went by this method because this will easily demonstrate the definition, and it is better to understand.
So can you show previous slide?
Yeah. Once you're done, please let me know so that I could go ahead.
Yes, done, sir.
So less than cumulative frequency, more than cumulative frequency, both are done. I'll go to the next point now. That is the relative frequency.
Sir,
Yes.
sir, for more than cumulative frequency, can you tell how that 40 km did we start from bottom to top?
Just a minute. Saurav, what does the definition say? When I want to find the more than cumulative frequency for a certain class, how many observations do you take? Which observations do you consider under that?
More than or equal to lower limit.
Uh-huh. So let's come to the first class. What is the lower limit for the first class?
0.
0. So how many observations or how many individuals are getting more than 0 marks?
This 5 and
So huh? Don't worry, everyone is trying to understand and everyone here is to learn. So whatever you feel, you say it out. Even if it is wrong, we'll discuss it. No problem.
more than
So
0, right?
yes.
All means is 5 all frequencies.
What do we mean by 5? What is the meaning of 5 here?
It's it's the frequencies.
What do we mean? So if there are 40 students who are appearing for the test and this is the data, then what will this 5 mean? We have done the distribution yesterday, right?
Yes, we did.
Yes. So what was the meaning there? What was the meaning of frequency?
The number of observations in a class.
Yes. So what if the students are appearing for the test and these interval represent the marks? So what will this 5 mean?
Observations.
No, no. With respect to this example that I'm talking, students are
Huh.
giving an exam and their marks are recorded in this manner. So then what will this 5 mean? Simple,
Um,
in simple way, what are the observations in this context? Anyone else who can answer this? Let's have a discussion on this. What will the 5 mean?
So the number of students who scored marks between 0 and
So
10.
yes, so exactly. So 5 is the number of students who have scored marks in the interval 0 to 10. Similarly, Saurav, 12 will be
the students who scored marks in the range 10 to 20. Sorry,
20.
10 to 20. Okay.
And 15, the number of students who have scored marks between 20 to 30.
20 to
This is the
30.
pattern. Now you need
Okay.
to answer me. So, how many students have scored more than 0 marks? How many students are there who have scored more than 0 marks?
40 there are.
Yes, exactly. So, that will be the total of this, all of these,
Yes.
right? So, the total of this is 40. So, all the students have scored more than 40 marks. Now, how many students have scored more than 10 marks?
Two only this 10 to 20 and 20 to 30.
Only 20 to 30?
No, 10 to 20 and 20 to 30.
Only these many students have scored more than 10 marks?
35.
And how do you get that, Saurav? So, what will you subtract?
We'll subtract by 5 initially because these many students have scored marks in the range of 0 to 10.
Exactly. Now, is it clear?
Yes, now it is clear.
So, now let's go ahead. The next is the relative frequency. So, in some cases, what may happen is the groups that we have, the intervals, say I have 0 to 10, 10 to 20, and there are two groups. So, 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. Okay, you have class division A, say division A. This division have say 40 students, and the distribution is 5, 8, 12, 7, 8. Which is, yes, and division B is having say 100 students, and the distribution is 25, 10, 15, 25, 25. And I want to compare them now. Okay, and I need to find out to how many students have more than 20 marks, how many students have this. But actual frequency, if you see for both division A and division B, the total number of observations is different. Okay, so when you talk in terms of percent, say 20% students failed in division A, and what are the number of percentage of the students who have failed in division B? So using actual count, you cannot actually compare them, right? Because their strength is different. And that's why what you do is you talk in terms of percent. Okay. So comparing using actual numbers becomes difficult. Okay. Whenever the frequencies are different. I hope you are convinced with this, Dhruv, Bafna.
Yes, sir.
Yes. So in such type of cases, what we do is we talk in terms of the relative frequency. What does the relative frequency say? Relative frequency, the formula is a relative frequency. We need to take the in this case the actual frequency upon total frequency. Total frequency. What do I mean by this actual frequency? By frequency of class, right? So what I'm going to do is the total frequency is 40. So 5 by 40, which is 1 by uh, 8. This is going to be 1 by 5. This is going to be 12 by 40. Similarly, I can get the frequencies over here. So that is going to be 1 by 4, 1 by 10, 15 by 100. And now you can compare these two numbers, right? So now I can compare these two numbers. I can find the less than cumulative frequency, more than cumulative frequency, and I can do all the things. So whenever there is a comparison, so two different frequency distributions may not have the same total frequency. Hence, for the purpose of comparison and interpretation, it is better to express the frequency of class in terms of a proportion. That's all the relative frequency is. This is everything is there in the notes, but you still write it down in the definition or the formula for relative frequency. And remember that the relative frequency is used to compare the data when the frequencies are not same for more divisions. Clear? Fine. Now we will move to the graphical representation of the data. Graphical
So
representation.
can you please repeat the slide? Thank you, sir.
Yes.
Done, sir.
Yes. So I said that the next we need to go to the graphical representation of the data. So there are graphical representations. But before going to the actual definition, I'll just take an example and I'll see what type of graphical representation you can tell me for the given data, and we'll name it. The size of farm, the number of farms. So 1 to 20 hectares. There are 12 farms in a district. From 21 to 40, there are 38 farms in a district. 41 to 60 hectares, there are 16 farms in a district. 61 to 80, there are 5 farms. And 81 hectares to 100 hectares, there are 3 farms. So how can we give a graphical representation to this data?
Sir, I think first we need to make the intervals same.
Intervals on
No, we have to make it same, like it is variable now 1 to 20, then 21 to 40.
okay.
Then maybe we
Uh,
need to
it is
okay.
all same. I mean, they are of equal lengths, by the way. The lengths are equal.
Okay. Okay. No, but the okay, got it.
I think he's saying that we should make them
They should make the
exclusive intervals, like 1 to
yes.
20.5, 20.5 to 40.
That we can do. Okay, fine. We'll consider it done. So I'll make it say 1 to 20.5, 0.5 to 20.5, then 20.5 to 40.5, 40.5 to 60.5, then 60.5 to 80.5, then
So can
80.5.
we do a bar graph also now if we don't make them?
Uh, can you repeat?
So can we make bar graph also now if we don't want to make this intervals same?
For bar graphs, intervals need to be of the inclusive form. Yeah, exclusive form. Sorry, it is mandatory. So the
So for this
first
data,
type
we can.
of yes, tell me, Manas.
I was just saying that for this data, we can use a histogram
Yes, we
because
have to
it's
use the histogram. Bar graphs. I mean, the bar graphs that we have, those are uh, kind of those can be distinct also. But in histogram, there's a condition that there shouldn't be the gaps between these. So whenever we have this histogram, so we need to make those intervals of exclusive form. Okay, and then only I can go for the histogram. So what is a histogram first of all? So histogram is the way by which you can graphically represent the frequency distribution. First thing, so it is a series of adjacent rectangles which are erected on the x-axis with class interval as their base. Okay, so in this case, I'll take x-axis, y-axis, On x-axis, I'll take the class intervals 0.5. The first class interval is 0.5 to 20.5. 0.5 to 20.5. Then 20.5 to 40.5. Then 40.5, 60.5, 80.5, and 100.5. Now 0.5 to 20.5, and what we do is we have class intervals on the x-axis, and then the frequencies are taken on the y-axis. So say here it is 12. So I'll make a rectangle whose base is on the x-axis and its height is taken as the frequency. Then 20.5 to 40.5, it is 38. Then there is 16. Then it is 5. And it is 3. So the most common way of representing a data is the histogram. Okay, in many of the cases histogram is used, and it is very much efficient to express the data, which is very much understandable also. So I'll just write the definition here and the conditions which are to be followed whenever you are dealing with histogram. So histogram, it is a series just a minute. Okay, sorry. So it is a series of rectangles, the series of rectangles erected on x-axis with class intervals as the base and frequency along y-axis. Then, so since the base of rectangle is actually the class width, so there is a slight difference in the procedure of construction. So in some cases, what may happen is your class intervals may vary. So in this case, those were of equal length, say 20 units. So it may happen that the class widths are not same. Even the frequency classes of unequal width, so the height may differ accordingly. So what we need to do is we need to consider the two cases. So first of all, let me just write down the conditions. First one, in case of inclusive, just like our example, in case of inclusive method, inclusive distribution, in case of inclusive distribution, extend the intervals, extend the intervals to make distribution exclusive. So those are class boundaries, if you remember. So in the previous one, we have seen that the point at which till which we can extend, that is nothing but the class boundaries. Now, so since the base of rectangle is actually a class width, I'll write it down the next page. So if the classes of equal width, then there is no problem. We can directly raise the histograms on x-axis. Class of equal width, there's no problem. If the classes of unequal width are there, remember this case, if the classes are of unequal width, then what we do is we will convert the frequency to uh, the frequency density by using the formula. Then the height of rectangle is the frequency density, where frequency density is equal to class frequency upon class width. So if your intervals are not of the same width, then we'll change the height of the rectangles according to their width, and this is the formula. So height will be considered as the frequency density, and the formula is class frequency upon class width. So that is all about the frequency distribution.
Sir, can you show the previous slide once?
By the time you do this, I'll give you the link. Please mark your attendance.
Hello, sir.
Yes,
I don't know my roll number, so what do I do? This is my
put zero
first
zero.
class. So, okay,
Yes,
thank
no
you.
one knows the roll number. Yeah, so you can simply put 00.
Okay, thank you.
Yeah.
Excuse me, sir.
Yes.
Sir, can you please send the link again? I
Yes.
was disconnected at that time.
You just need to go to chat box. It is not there?
No, sir.
Okay.
Thank
Is it there now?
thank you, sir. Yes, sir.
Sir, have you already given us some notes or something to refer? Or
No, no, nothing. I told you
okay,
wait
sir.
for this week.
Okay, sir. Because I joined a bit late, so I was not aware.
Okay.
That's why I had to ask.
Yeah, no problem. Fine, we'll stop here.